Good morning, friends. In this session, we'll learn about the proof of geometric series. We all know sum of geometric series when there are n terms and the ratio is r and the first term is a. The sum is a into 1 minus r power n by 1 minus r. Similarly, sum of infinite series where the ratio is between minus 1 to 1, right? That then we also know the sum of infinite series is a by 1 minus r, right? We know both these formulas, but let us see how to derive these formulas. It is very important to have this conceptual understanding, right? This is very easy. The derivation is very easy. It will take 2 minutes. Let's take geometric series. So, for example, this is a geometric series 1, 2, 4, 8, 16. Every number is multiplied by 2, right? The ratio is 2. 1 into 2 is 2, 2 into 2 is 4, 4 into 2 is 8, 8 into 2 is 16. In this case, the ratio is half. 1 into half is half. Half into 1 by 2, 1 by 4. 1 by 2 into 1, 1 by 4 into 1 by 2, 1 by 8. 1 by 8 into 1 by 2 is 1 by 16. So, in the first case, the ratio is 2. In the second case, the ratio is half. We denote it as AR square, AR cube, because every number divided by the previous number is R. AR square by AR is R, AR cube by AR square is R, like this. Right. Let us denote the sum of all of this up to n terms. Okay. Let's take n terms. N terms, the nth term would be a into r power n minus 1. The fourth term is ar cube, right? 1, 2, 3, 4. Similarly, nth term is a into r power n minus 1. This is for n terms. A plus ar square plus whatever ar power n minus 1. This is the sum. Let's do a simple thing. The same as let's multiply with r. Okay, s into r. Then what will become? A into r will become ar into r will become ar square into r will become ar cube, whatever, and this final nth term, ar power n minus 1 into r will become ar power n, right? Similarly, ar power n minus 2 will become ar power n minus 1. The same. Here, here also there are n terms, here also there are n terms, right? Here also in this line also, in this term also there are n terms, in this also n terms. Now, if you see, if you subtract s minus this sr minus s, what will become? These all things will cancel out. Ar will cancel out, ar square will cancel out, ar power n minus 1, these also will cancel out. Only this thing will be left and this thing will be left. So what is this? Sr minus s is equal to ar power n minus a. Remaining all will cancel out. This all will cancel out. Right. So let's just simplify this. S into r minus 1, which is this, is equal to a into r power n minus 1. What does this mean? S is equal to ar power n minus 1 by r minus 1. Right. So what is our s? S is the sum of all of this, right? Sum of n terms. So here we go. The sum of n terms is a into r power n minus 1 by r minus 1. We have done in this case SR minus S. If you do S minus SR, then it's the same thing, right? Then instead of a into r power n minus 1 by r minus 1, it will just be the reverse. A into 1 minus r power n by 1 minus r. Just the numerator and denominator will just get multiplied by minus 1. Right. If you do S minus SR, then you will get this result. SR minus S, you will get this result. But both are same. This result you can just multiply by minus 1. We'll get this one. And generally, we use this notation because it is helpful. It is helpful in places where there is an infinite series or in other places also. Right? When the ratio is small, we prefer this kind of notation. Right? Now let's expand this notation. Okay. A into 1 by 1 minus r power n, which is equal to a by 1 minus r minus a into r power n by 1 minus r. Okay, let's take the special case where r is lying between minus 1 and 1. Okay, r is a proper fraction. What is a proper fraction? Proper fraction means numerator is smaller than denominator. This could be negative proper fraction, which is this, and positive proper fraction, which is this. Okay, let's assume that r is a proper fraction. where numerator is smaller than denominator. Then what will happen? When n becomes very big, when n becomes very big, r power n becomes very small, right? Any proper fraction. Let's take half. Half power square 1 by 4 is actually smaller than half, right? If you increase the power, this r power n will reduce further and further. Ultimately, it will become very close to zero. If you make it infinity, as n tends to infinity, r power n tends to zero. What does that mean? If r power n is going to become zero, this expression a into r power n by 1 minus r, this also will tend to become zero. Right. So this entire expression will become zero. Then what is our sum again? The sum when r is lying between minus 1 and 1, this part will become zero and only this part will be left. A by 1 minus r. This is how we get sum of infinite series. For example, this one. Infinite series where r is less than 1 or r is actually between minus 1 and 1. Here in this case half, r is between minus 1 and 1. So the sum of this series 1 half 1 by 4 1 by 8 is 1 by 1 minus r, which is 1 by 1 minus 2 is 1 by 1 by 2, which is equal to 2. The sum of this series is equal to 2. Right. You can check it manually also. 1, then half 1.5, 1.75, etc. etc. Right. The sum, as you keep on adding more and more terms, it will get close to 2, but it will never cross 2. This is the sum of infinite series. Right. Sum of infinite series is a by 1 minus r, because this expression will become 0 when n becomes big. Right. Hope you understood this. This is a simple proof. Right. We did nothing. We just wrote the summation and then multiplied with r and then just subtracted and derived this expression. And then in special case where r is lying between minus 1 and 1, we realized this expression will become close to 0. So only this one will be left. Right. See, this is a beautiful proof. Hope you enjoyed this. If you have any doubts or if you have any comments, please mention in the comments. Thank you guys.